Dividing radicals containing binomials in the denominator. In order to remove these radicals from the denominator, we need to again move them up. But again, we do not want any radicals remaining in the denominator. So in order to remove both of these radicals from the denominator, we multiply this by a binomial, which is called the conjugate. Okay? And the conjugate is the same binomial as root 6 minus 10, but with the opposite sign. So if this is a minus, the conjugate of root 6 minus 10 would be root 6 plus root 10. So this is what we want to multiply the numerator and denominator by our radical expression. So I'm going to multiply the top and bottom by root 6 plus root 10. Now when I multiply these values, this is going back to multiplying radicals. I have a binomial here and a binomial here, so I need to FOIL the top. When I do this, first times first, I'm going to get a root 12. Outside times outside, I'm going to get a plus root 20. Inside times inside, I'm going to get a plus 5 root 6. And then last times last, I'm going to get a plus 5 root 10. Now this is all being divided by the bottom. So when I FOIL the bottom, which I'm going to do as well because I have a binomial times a binomial, I'm going to get a root 6 times a root 6, which is a root 36. Root 6 times root 10 would be plus root 60. And negative root 10 times a positive root 6 would be a minus root 60. And then a negative root 10 times a negative root 10 would be a minus root 100. So what happens when we FOIL the denominator is, and this only works when you're multiplying by the conjugate, what happens is these middle terms will always cancel each other out. So if you notice, we get a plus root 60 and a negative root 60. Those are simply going to cancel each other out. And now I can simplify my numerator and simplify my denominator. So I'm going to break down the 12 like we always do. It would be 4 times 3. I'm going to break down the 20, which would be 4 times 5. 5 root 6 cannot be simplified any further. 5 root 10 also cannot be simplified any further. And then in the denominator, what happens is both of these first and outside values end up to be perfect squares. So the square root of 36 is just 6. The square root of 100 is just minus 10. Finally, we're going to simplify the top one last time. The square root of 4, when I bring it outside, becomes 2 root 3. The square root of 4 again is 2 root 5 plus 5 root 6 plus 5 root 10. All over. Now I'm going to evaluate here. 6 minus 10 is negative 4. Now I'm going to look to see if I can collect any like radicals in my numerator, and I can't. They're all different. So I would stop there, and this would be my final answer. So that is how you divide radicals with a binomial denominator.